Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 11 from the old C12 January 2020 paper from the International A-Level Edexcel board. This question is about equations of circles. And here we have a diagram given with this circle drawn in it. And we're told that the equation of this circle is x squared plus y squared minus 6x plus 9y plus 18 equals 0. And we're asked to find the coordinates of the center of the circle and the exact value of the radius of this circle. So we know that when we rewrite the equation of the circle in the form as follows: x minus some constant a squared plus y minus some constant b squared equals r squared. From this we can extract the center of the circle as the x value that makes this bracket 0, which would be a, the y value that makes this bracket 0, which would be b, and the radius is basically just the square root of this number over here, which would be r. So if we write it in this form, okay, then we can extract the information needed very easily for us to answer this question. So we have to take the equation and rewrite it in that form. So what I'm going to do first is I'm going to take the x squared and the x term and write them next to each other. So x squared minus 6x, and then the y squared and the y term, y squared plus 9y. And I'm also going to subtract 18 from both sides to get rid of this. So now I have x squared minus 6x, which will give me x minus 3 squared. Now if I leave it like this, it's going to give me x squared minus 6x plus 9. I don't want the plus 9, so I'm going to take away 9. So this is basically completing the square for that section there. And then for the next section, I'm going to have y plus a half of the coefficient. So 9 divided by 2. I'll just leave it as 9 over 2 to make it easier for us. Squared. And then I've got to take away the square of this number, y, because when I square this bracket, I'm going to get y squared. I'm going to get plus 9y. And then I'm going to get plus 81 over 4, which I don't want, so I'm going to take it away. So minus 81 over 4 equals negative 18. So now I want to get the constants all on this side. So I've got x minus 3 squared plus y plus 9 over 4 squared equals, I've got minus 18 plus 9 and plus 81 over 4. Okay, so this gives me x minus 3 squared plus y plus 9 over 4 squared equals, that's going to be minus 9. So I've got 81 over 4 minus 9. 9 is 36 over 4, so I'll write that as minus 36 over 4. And 81 minus 36 is 46, 56. That's going to give me 40. 36 to 76 is 40 plus 5, 45. That's going to give me 45 over 4. Okay, so I have x minus 3 squared plus y plus 9 over 2 squared equals 45 over 4. So from here I can work out that for the answer to part 1, the center of this circle is going to be given as the x value that makes that 0, which is 3, and the y value that makes that bracket 0, which is minus 9 over 2. I'll leave it as that fraction form for now. And number 2, part 2, I have to work out the radius. Now the radius is the square root of 45 over 4. Okay, so I can see that that's going to give me something over 2. And the square root of 45 is 9 times 5. So I'm going to get 3 root 5. So it's 3 times root 5 over 2 in its simplest surd form. And the question does say give the exact value of the radius. So that's the answer. Those are the answers to part A of the question. We've got the center and we've got the radius of the circle. Okay, now for part B of question. It says line L is parallel to the y-axis and intersects C at points P and Q. So here we have our circle. Okay, we've got the diagram from the last page. And it tells us line L is parallel to the y-axis. So it's a vertical line and intersects the C at the points P and Q. Given the length PQ is 5, find 2 distinct equations for L. Okay, so basically we've got one possible, we've got a vertical line, we've got two vertical lines. Let me make that a bit thinner. They have to be vertical because they have to be parallel to the y-axis. I'll change the color as well. Okay, so that's, let's say that's one of the lines. And then we have another line. It's gone up there. Okay, there's another line. Okay, and what we know is that they're both the same length. Like, for example, this is P, this is Q. Let's say this is P, and this is Q. And this is a second, like, let's call this P1 and Q1. P1 and Q1, and this is a second kind of option for P, P2 and Q2. Okay, so the length of this line is 5 units. This is also 5 units. Now the center of the circle is here. Well, we know the radius of the circle is, as we found earlier. So the radius of the circle is this and this. And we know the radius of the circle is 3 root 5 over 2. And we also know the center of the circle is 3 and minus 9 over 4. Okay, so the x value of this is 3. All right, x value of this is 3. Now, I want to find the equation of these two lines, line 1 and line 2, let's say. So if I know this distance here, if I know this distance here, if I know that distance, which is like the perpendicular distance of the line P from the center, I know that distance here, okay, I can then find the equation of this line, because this is going to be 3 plus that distance, let's call it x, okay, and then this is going to be 3 minus that distance is also x here. Okay, so the equation of line 1 is going to be 3 plus x, and the equation is going to be basically, let me not call it x actually, because x is the name of the equation. Okay, so let me call it something else. Let me call it distance d. That's going to be d, and that's going to be d. So the equation of line 1 is going to be given by x equals 3 plus d. And for line 2, it's going to be x equals 3 minus d. Okay, because x equals 3 would be the line that goes through the center, vertical line. That's d away from the center that way, and that's d away from the center that way. And that distance will be the same on this side, because chords which are the same length are the same distance away from the center of the circle. So if that's d, this will also be d if that's also 5 centimeters or 5 units. Okay, so if I work out the value of d, which I can do because I know, what do I know? I know that this is the radius. I know this is 5, so this is 2.5. Because this is going to cut it in exactly 2 halves. We know that when the radius meets the chord at right angles, it cuts the chord into 2 equal halves. So certain properties of circles we need to know to answer this question. So that's one of the properties of circles we need to know, is that when a chord is bisected by when a chord meets the radius at 90 degrees, it's bisected. So this is 2.5. This is our d. And this is our radius, which is 3 times root 5 over 2. Okay, so this is 2.5, which you can say is 5 over 2. Keep everything in fraction form. So therefore, the value of d is going to be, by Pythagoras, the square root of 3 root 5 over 2 squared minus 5 over 2 squared. So d is going to be the square root of, this is going to be 9 times 5, which is 45 over 2, minus 45 over 4, sorry, minus 25 over 4. Okay, that gives us 20 over 4, which is 5. So d is equal to the root of 5. That's 45 minus 20, which is going to be 20. 45 minus 25, which is 20. 20 over 4 is 5. So D is going to be root 5. So therefore, the equation of line 1 is going to be x equals 3 plus root 5. And for line 2 is going to be x equals 3 minus root 5. So those are the two equations of those lines, those vertical lines, which cut the circle in such a way that the chord formed is 5 units. Okay, so that's something that's important for us to understand. So in this question here, understanding the properties of chords in circles is important. One of them is that if two chords are the same length, they're equidistant from the center. So the distance from here to here is the same as the distance from here to here. And also we know that when the radius cuts the chord at right angles, it bisects the chord. So that's how we knew this is 2.5. So those properties of circles are very important for us to recall for such questions as this. And those were learnt in IGCSE. They're not really taught formally in the AS course, so they're things you have to remember from the past. And the best way to be prepared for such type of questions is to practice lots of different questions, so you get exposed to different types of questions that could come up. Okay, so that concludes question number 11 from this, and I hope that was clear. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic, the end of topic worksheet that I took this, or I've used this question in, you can find in the playlist in the bottom right here. You can subscribe to my channel by clicking on this link at the top here, and at the bottom here you'll find also a playlist for all the other questions dealing with the equations of circles I've made. Thank you for watching, and see you soon.